Hello there, once again this is G, and if you're getting bored of oxygen not included, this is a video for you. And if you find it helpful, then smash that like button for the algorithm. Today, we're going to look at melting sulfur, which we will use for natural tiles in the next episode. Now, I know what you're going to say. Gee, Spaced Out has sulfur geysers, so why do I need this? Well, let's assume for a moment that our map has none of those, and that all we've got is a big ol' sour gas boiler. Now, if you want to see how to make a large sour gas boiler, I've linked a video by Tony Advanced in the description below. But now, let's have a look at this machine here. Okay, so it's made of two stages. So the preheater on the left in yellow and the melter on the right in red. And of course, this can be reversed as needed. Now, unless you're warming up sulfur in the sour gas boiler or elsewhere, it usually comes out at -170. And here in the example, it has -179. And to melt it, you need to get it to about 115, 120, and here we have it at 160. So that gives us a range of about 300 degrees, give or take. And to get us most of the way there, what we need to do is convey the sulfur through this preheater right here on the left. And this is made of mostly a large diamond block with a couple of diamond temperature plates at the bottom. And all this is heated by this tepidizer here. And once preheated, the sulfur is conveyed to the melter on the right over here. And let me show you the conveyor setup. Now, what you see here is the right side is a little bit different. We actually have a sulfur conveyor loop, and it's being topped up at this bridge, which is controlled by the shutoff here. And we have a second loop here on the right, and this is made of a diamond conveyor. And diamond is being looped through here, and it's taking heat from this aqua tuner chamber, and it's bringing it down through this diamond block and exchanging it with the sulfur. Essentially, this is a diamond block heat exchanger. This is very similar to regolith melter type setups. As it turns out, diamond conveyor loops are excellent at transferring heat over a large temperature range, and this is very handy in a lot of setups. But in our case, the diamond loop is getting heat from this aqua tuner here, which is submerged in supercoolant. And it's also using supercoolant for the plumbing. Let me show you. Okay, so here we have a simple loop with a little bypass bridge. And the loop is actually taking the heat from this tepidizer. So really the tepidizer here is the only source of heat in the entire setup. And then it's bringing this heat at a higher temperature into this chamber. And there is a diamond plate back here, which is exchanging heat efficiently with these diamonds here. And that in turn efficiently transfers heat to this diamond loop, which then heats the sulfur below. At the bottom, we have a steel pump, which is going through this liquid valve. This is set at 5 kilos per second. And this is optional, but it helps to even out the flow. And I found that this particular machine gives you about 5 kilos per second maximum of molten sulfur once it's filled up and going at full rate. At the top, everything's powered by a couple large transformers. This can really be placed anywhere, however you want. But let me show you the wiring. Pretty straightforward. Finally, let's have a look at automation. First of all, we have a conveyor shutoff here. And this is controlled by a hydro sensor over here, which turns off the conveyor if the level of liquid sulfur is too high. And you just want to avoid overflowing. This same hydro sensor also controls this end gate, which controls the aqua tuner. So if the level of liquid sulfur is too high, the aqua tuner will turn off. The aqua tuner will also turn off if the temperature in this chamber is too high. And currently it's set at 180, but we could set it at 300 when you're starting. And also, for the submerging liquid, we're using supercoolant, as I mentioned. But you can also use petroleum, and this just won't be as efficient. And the last bit of automation here is the end gate, and this is controlling the liquid pump. And the liquid pump is controlled by this hydro sensor up here, which if there's not enough liquid, it will not start the pump. So the pump will only start once the level of liquid reaches the top here. The other thing that controls this pump is if the chamber or the tank where this liquid is being sent is too full. In this case, we have a chamber down here, and if it hits the sensor, it will stop. Now, we'll talk about that farm in another video, but for now, this is all I have for you. So let's go melt some sulfur. This has been Greasy Hammer, and if you found this video helpful, then smash that like button and subscribe if you want to see more. Thank you very much. Bye-bye.